All right, I guess we'll get started here. I apologize for my tardiness. Welcome to another Common Law Study Group, folks. I'm your host, Ram Vedam from Atlanta Functional Programming. Today, we'll be discussing the series library, a library that was was originally proposed to be a part of the Common Lisp standard, but sort of fell short from actually getting into the standard. Was actually one of the alternatives to looping and iteration, which obviously we covered in past episodes with the loop macro. Just give me a second here. I forgot that I needed to clear my REPL. I wanted to today cover a little bit of the basis of the series library and what you can do with it. I'm not going to be able to cover everything because I recently found out that there was the follow-up paper that actually went into some of the implementations of series. I was able to find it on MIT's archive website. After this, I will go ahead and post links to the papers if you guys are interested in it. These are, I would say, supplementary material to the actual API documentation that's in Common Lisp the Language 2nd edition. A couple things to note that before we get started is some weird things I did notice primarily when I was playing around with series over the weekend. One thing is a couple of the functions that are in the documentation, primarily the reader macros. It looks like in the quick Lisp package that's available for you to load, those reader macros no longer exist, and I will go ahead and present which reader macros I am talking about. Additionally, there is some stuff about series that may be a bit foreign because we never really discussed it up until this point, but I think this will definitely spawn that discussion, primarily the features of the Common Lisp type system, because my experiences and my exploration into the series library have made me realize that this is one of the examples of really leveraging the Common Lisp type system, because it really leverages it, because in order to create optimized code over time. I wanted to mention that up front before we get started, just so that when we go through some of the simple code examples, it doesn't throw people off. So, like I mentioned, can everybody see my screen? Is the font size good?
Yes, it looks much better than your original Emacs too.
I knew that you were going to say that.
Yeah, that's good.
So, series, like I mentioned, was a library that was written by Dr. Richard C. Waters. It was a macro package that actually incorporates a data type, a data structure that he created, that in the documentation in the appendix that you would see if you read the Common Lisp the Language 2nd edition appendix, which I encourage you guys to do. This data type essentially combines aspects of sequences and strings. The motivation behind it is and this was known even back then, and I will tell you, the series research and the series data type, I would say, was actually part of a PhD thesis that Dr. Waters wrote in the late 70s and early 80s. Back then, they realized very easily that using and leveraging functional composition and really operating mainly on data structures in a lot of, like maybe 80% of day-to-day cases, writing it in a functional style led to better code. And you can easily leverage certain optimization techniques to get code that is as efficient as the iterative versions. So one of the goals of the series library, actually the main goal, was to actually express computations with these data types without incurring any sort of runtime overhead. some of the library features that we'll see as we go through it is efficient transformation of series expressions. You have a built-in, like I said, a built-in data type to represent series, and there's about I think a few dozen functions already available that are split into three categories for your use. So for immediate use, if you want to just do some common tasks like going through integers or going through a file or whatever, those are actually available for you. The three types of categories, and I would almost say that these are like implicit namespaces in the library, although they're actually exported as part of the main series library, are scanners, transducers, and collectors. Sort of giving you, if you think about it, what we normally associate, like scanners are what you would do to essentially access a data source and produce a series. Transducers are your transformation sequences, and collectors are what you ultimately want to do at the end after you're done with your transformations. So they all hook in together in a linear style. One of the benefits of doing this style is obviously anybody who's done loop-free programming, especially in functional languages like, say, Clojure or Ruby, or even like using Python's features, you would end up realizing that loop-free programming tends to impose sort of a declarative style rather than an imperative style of programming. And those expressions are easier to maintain, better to read. They're far more concise, so you know where you did something wrong. And having these part of a library that's been battle tested is kind of actually very, very useful. Of course, there are cases where you don't want to necessarily leverage series, and in those cases, actually, series ends up being slower than trying to manually test the code. Now, I don't know how much slower. From my tests, it doesn't look it's that much negligible. It's almost kind of like a wash. But I've only been testing with like integers. I haven't actually leveraged this in a particularly real world program because I've only been recently leveraging this, and I wanted to discuss about this library and some of its kind of uses.
Could I chime in there for a second?
Yeah, sure. Go ahead.
As far as that slowdown is concerned,
Mm-hmm.
that would be an issue if you're used to operating at the SBCL, reaching near C performance kind of style of code. But when you think about it, series expressions are actually very similar to one of Clojure's core data types, the lazy sequence.
Right.
And so when series isn't able to optimize something into an efficient loop, it's basically doing the same kind of thing that Clojure does with lazy sequences, and the overhead there is pretty minimal anyway. So I wouldn't expect it actually to become a serious issue, and it certainly isn't a serious issue if you're sort of doing the same kinds of things you would be using Clojure's lazy sequence libraries for.
Actually, you bring up a very good point, Elijah, because that's one thing I did notice. There are a lot of parallels with series itself, the data type, and lazy sequences and other in Clojure, and even Haskell for that matter. I think the approach that Haskell and Clojure may have taken behind the scenes, and this is just my speculation, is some of the techniques that were probably mentioned in that second paper that I mentioned that I just only recently found is available for me to read on the theory and implementation of series. And what's interesting about that paper, from my cursory overlooking of it, is that he not only provides some of the issues on implementing series in Common Lisp, but he also says that this is actually a generic data type that you can actually leverage and implement in other languages. So series itself is actually almost a generic concept, and this is just a particular macro package that is a concrete implementation of that generic concept. So I think it's kind of useful to at least know how it's implemented. Unfortunately, we won't be able to go through that just because, again, I haven't had a chance to really thoroughly go through that paper and see what the advantages and disadvantages of how they implemented it, and even try and implement it myself to see what given modern language features, especially in other languages or even in Common Lisp, because at the time that it was invented and what's available now are kind of different, right? Especially if you're using a platform-specific extensions that are in say SBCL or CCL or whatever. So I'm kind of curious if there are maybe opportunities to even clean up or improve the series library. But again, that's based on what that paper says and my understanding of it.
It sort of depends on what approach you're talking about as far as optimizing it goes, because like series is sort of two separate parts, I guess you could say. There's the functionality of the individual components, and then there's actually the series compiler, which goes through and actually optimizes stuff.
Right. And we'll be covering a little bit of that just today. As you probably already know, I'm assuming you've played around with series yourself. One of the
Not
features
as much as I would like, but I've read some of the internals.
I've also started reading the internals, and what's interesting is and this is what I want to bring up, and this is my next point, is one of the caveat of leveraging series is that a lot of series expressions are statically analyzable, and a lot of it makes heavy use of the Common Lisp type system that's currently available. And I was kind of surprised by this. They're like, okay, you're going to end up doing types. If we can't figure out the types, we won't optimize your code. You need to be able to make it very easy for us to actually, figure out what types are available and so forth.
I mean, that sort of comes back to my point, though, about how if series doesn't actually optimize your code, you're basically just using the same kind of implementation that you have in Clojure, where it's entirely a runtime lazy sequence.
Right.
So while, when they're saying that you need to provide a lot of, type information, make it very clear how you structure your code so that our optimizer can actually do its job, that's removing a runtime overhead that most people actually are perfectly happy paying these days. To
Sure.
put it bluntly.
Understandable. I may not be in that camp, but I understand.
That's fair. Their point is that if you do really care about there being no runtime overhead, you need to work with the optimizer a bit.
Right.
If you're not as worried about that, using series functionally is fine, although I'm pretty sure it throws a bunch of warnings if it isn't able to optimize.
Yes, and I'll actually show a couple of examples of that.
Yeah.
It's pretty impressive. I still am not. And again, we won't be able to cover a lot of that. But we will cover a little bit of it in terms of like suppressing warnings and stuff. Just because again, it's not. Some of the examples are still not complete. I've primarily got a lot of basic examples to show you guys right now, but in the actual MIT paper, which is one thing I would like to actually re-implement, they actually leverage series to actually implement live variable analysis for compilers, which is, if you guys ever done live variable analysis for compilers, it's a very, 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 if you use loops, it's very, very unmaintainable. Like it looks very unwieldy in a lot of cases, and some of the series' features actually go and clean some of that up. Again, like some of the techniques, I looked at it and I'm like, this actually can actually clean up my code if I just leverage this standard library function in other languages. I've only implemented LVA in C++, but and I'm sure that I could do that in a functional way now. I'm sure if I implemented series, I could even do it much more cleaner than what is available currently. So this is an example of a series expression. Okay. As you can see, it is a straight line computation. One you can figure out by just looking at these data elements through the parser. As it reads in, it will know what types it is. And if you try actually running this guy, give me a second here. Maybe you can just do this. Just one. Okay. Because I don't think it will go through otherwise. All right. So if we go and run this guy the first time, you'll see that it will compile and won't actually throw us an error. There are some cases where this could actually leverage us an error, and I'll give you. And it's not necessarily an error; it's actually a warning. What series does is when you try to leverage a series in an expression, and the compiler can't figure out what that series is, it'll tell you things like non-series in data flow to series. It's trying to convert, so it's trying to pass in something that it couldn't figure out whether it's a series object or not. Some of you who have come from other languages that have lazy evaluated sequences, I know Clojure took the Haskell approach of providing some features like take and drop and all the standard drop while and these APIs. What Series does, it has a similar kind of thing, primarily through its subseries functionality. So in this example, I'm creating an unbounded collection here. That essentially is an unbounded collection of the even integers, and it will grab the first 5 of them, and it will go ahead and return both the list that it actually received and the sum of the list. So when we run this guy, you'll actually see when I compiled the expression, it threw a warning. Let me show you what it actually threw here. And what it's throwing up is it can't, in the data flow graph, and what Series does is it takes the expression, parses it, and creates a data flow graph from the initial instantiation of the series object. And if it can't figure out what is actually bound to, and it's primarily due to, I think, the let expression, it will go ahead and say, sorry, I can't figure out what you're trying to do here. And it will run as if you were running a normal Lisp expression, and will try and iterate through it as is.
Yeah, that's a flaw, in my opinion, of how Series designed their API.
Yeah.
They can only capture, they can only do the data flow analysis starting from some, series symbol, right? Yeah. Some symbol that Series exports.
Right.
And so only, sub-expressions of some form starting with a symbol that Series exports, are part of a particular thing there. And so when Series does its optimization, if you want it to handle that entire expression, you have to be using Series' version of let. And Series does have a version of let. I forget where it comes from.
It does have a version of let, but I didn't think that. I was looking at the main package earlier. Actually, I think it
doesn't export it in the main package, because otherwise you wouldn't be able to use it with CL.
Right. So what I have to do is I may have to do this. I think. Hold on.
Double colon.
Double colon.
Double colon. Oh, it's not exported. That's right. Thank you.
Yeah, and now that'll compile properly without warnings.
Ah, perfect. Okay. So I knew that there was something available there, but I just could not for the.
Yeah, there's one for let and there's one for defun as well, and you basically just have to import those yourself if you want to use them.
But even with defun, defun, you can actually leverage. I'm sorry to interrupt. I just want to mention this point. With defun, you don't have to necessarily leverage defun, because they actually added optimizable series function. So that's actually kind of useful, because now you can say, "Oh, I am using Series. Don't worry, I'm using Series."
I'm pretty sure you do actually need to use Series as defun for that declaration to do anything.
This actually, I think, it worked. So let me show you this. So it compiled no warnings. Let me go and use it. Simple.
Because there is no portable way to trigger code generation via declaration.
So I'll just do it this way. Scan range from 0 up to 10. And I try to reread that at that point then. Yeah. Okay. And obviously I need to have print. And if I run this, it's not of type array. Wait a second. Did I mess up here? Oh, I'm an idiot. I actually internally leverage scan, so I don't need to actually do this. I could just do a standard loop from 0 to 10, collecting 9. So I missed something. I apologize. I'm an idiot.
4i from.
Yeah, 4i. Yeah, I'm an idiot. All
No,
right.
you're fine.
All right.
Yeah, so that shouldn't be optimized. Like Elijah was saying, you actually have to go through the CLTL2 API for parsing the declare form.
So if you're saying this,
there's no portable way to do that.
Yeah, double colon also.
Oh yeah.
You should have to do it for the optimizable series function symbol because that one is exported. I'm pretty confident, anyway. If it wasn't, SBCL would have yelled at you because you have to declare declarations. I love how there is actually a declaration that is always used to me. But if you try and use a declaration that hasn't been declared itself, SBCL warns you. And so if that wasn't the one from the series thingy, you would have noticed. And also loop.
Yeah, I have to get rid of this guy, I think, actually.
Yeah, probably for the best.
Yeah, this guy doesn't need this. And hold on. I think I got it. All right. Ooh, being redefined as macro. It was previously defined.
Yeah, that's right.
Oh, got it. Give me a second. Let me restart my.
Optimizable series functions are actually macros.
That makes sense now. I was wondering why. Let me restart my Lisp just to be.
No, you can
clear.
just redefine it; it'll go away.
Yeah,
It'll be fine. I restarted it just to be in case.
that's fair.
Better safe. Sorry.
Assuming it actually does.
It
read
should. There it is.
Okay, yeah.
It took a little bit.
there.
Hold on. Oh, wait.
But yeah, in my opinion, they really ought to have provided a much more generic macro for, optimize all the code inside this code body. But I don't know of one, and that really annoys me.
Yeah.
Like, they should provide a with series optimizations macro.
Oh, I
Just wrap
completely
around the
agree.
body code.
But again, these things are. I think we can leverage. We can probably create them too and extend the library to do some of these.
Probably.
I've been looking at it, and it looks a fairly straightforward implementation. It's not. It's nothing too crazy. I'm still going through the compiler just to see what is going on. But right now, I'm just showing you what I was able to accomplish. Give me just 1 second. I will say file and compile. What is it saying now? Does not designate any package. Hold on. I thought I did a quick load here. No, I did not. I knew I forgot something. Now, for folks who are just joining in, I will put this up on our AFP GitHub page so you guys can take a look at it. Should work. Why is that not working? I'll just do it here and then compile it. Series. All right. This should not work, and it did. Good. Warning, collect as file. Okay, so that's my final one that I need to go and change. Just a side note, I will say that me getting used to Spacemacs has really helped improve my my experience. So this was a huge win. Thank you, Michael Fiano, for showing us that little tutorial.
Oh yeah, yep, no problem. I only scratched the surface. Just play around with it. It does some pretty cool things.
Yep.
Okay, so let me just go ahead and change my package here, and then we can get to this. All right, that's what I want to do. All right. So
Comma SS is the sync key binding, right, Michael?
Say again?
Comma SS is the sync key binding, right?
Yes.
Yeah. Just so you know, Ram, if you're in a file and you want to synchronize the REPL to that file and change the directory of your REPL to the directory of that file, comma SS.
Comma SS, like that.
Yeah.
Oh,
In normal state.
got it. Ah, thank you. Did not know that. All right. That's actually very useful. So let me go over here and let me compile this guy one more time and let me do this. Actually, that. Oh, that's right. Give me a second. I need to add a print here. Now it will work. Okay, so this is now no longer actually giving me that error in that warning about. And I didn't actually. We actually cleaned up the code a little bit too as well. This is what I was actually originally trying to get at, which is the fact that you can define additional series functions yourself. But as Elijah pointed out, series really is a meta compiler. It's a language that allows you to declare expressions. So a lot of the things that you're going to create in series, whether they be functions or macros, have to go through the series transformation process to ultimately give you common Lisp code that's going to be equivalent, and then it'll then be compiled to machine code. So it's almost like a two-stage process. It will first take the series expression, create common Lisp code, and then the common Lisp code will get compiled. Because of that, there are a couple of common Lisp, I guess you would say, macros and keywords that are in the series package that haven't been imported because of the fact that obviously if you imported them, it will complain with the CL user package. So this notation, if folks who are just joining in who aren't familiar with this, this is essentially getting to an implementation specific, an uninterned symbol that's inside the series package.
Unexported.
Yeah, unexported. Thank you. Unexported symbol that's inside the series package. So it's available for you to use, but beware that obviously the library author, if they go in and decide someday, oh, I'm going to just change this and remove it, then your code may be broken.
Yeah, I believe there's the series user package is also supplied by default, and that actually starts out having both the let and defun from the series package shadowing imported over top the ones from the CL package. That's actually how I discovered that was how they had that all working, because I knew that when I was in the series user package that I wasn't using the CL let or the CL defun, and I was like, okay, so where does that actually come from? And I eventually traced it down, but
hold on. I just did the wrong thing. I wanted to actually go and I actually had this open earlier, which I think is still available. And no, I don't have it open anymore. Oh well, okay. I'll deal with it later. Okay, so let's go through some of these things. We jumped a little bit ahead, but it's okay. One of the nice things about series is it will try, once you actually have the expression all correct and it's correctly statically analyzable, it will generate fairly efficient common Lisp code. Like this example that I show you here is exactly equivalent to this example. I don't believe if I do an expansion of this will actually show it, but we can try. It does. All right. So when we expand, let me see if I can do a resize here. Quick. Okay. Resize plus 10. Thank you. All right. Yes. Okay. So what I'm showing you here, folks, is the generated code when the macro expansion of series let. And as you can see already, it generates some symbols to actually go and coerce through and create our list, our unbounded list, as well as an initial sum. Just so you guys are aware, it basically is trying to collect x and then collect the sum of x from the first 5 even numbers. One main thing that was particularly, like I mentioned earlier, surprising to me, but made sense once I started thinking about it, is the fact that series does heavily leverage the types inside common Lisp types to generate very efficient code. So these declarations here, these type declarations, essentially are hints to the compiler saying, I'm promising you these numbers are, as you go through and generate the code for this, assume that number 797 is of type number and index 794 is of type integer, and so forth. And then what it does is it uses some techniques that we didn't really cover in our previous discussions. Primarily, I don't think we talked about how to use locally, for example, in other discussions. But we have touched base on using tag body and implementing essentially a loop using tag body. But you don't have to worry about using these in your own common Lisp code. In fact, I discourage you doing that. But if you're trying to create like a compiler, these are at your disposal to create some fairly efficient code where are possible. And you see that series is actually leveraging this to actually create fairly efficient code too as well. To create a series, there are a couple of functions available for you. Obviously, you have the series function, and this guy takes in an element, a quoted element, and it will return to you an unbounded series. So this is kind of like the lazy evaluated sequences in other languages that are available today that most people are hopefully familiar with. Let me just go down to this. So here, if I go and I apologize, I forgot to add this as a out of curiosity, when I evaluate, can everybody see my mini buffer? Can you guys see that? Is that too small?
Well, I mean,
No, that's fine.
Okay.
If you evaluate a form and the printed representation is too big, slide pops up a description buffer.
Okay.
In case you didn't notice.
Yeah, I just did.
Yeah.
So in this example here, series created an unbounded collection essentially of A's. It'll just keep printing A into there infinite ad nauseum. And
Thank you for reminding me. I gotta add that to my bug fix list. Slide description buffers can't be closed with Q. You actually have to manually close the buffer with buffer delete.
Yeah, I did that. Space BD has been my friend this entire.
I have to fix that. Thanks for reminding me.
And
also,
yes.
Presumably, you must have your print length set to 100.
I think I do actually. I haven't changed the defaults.
So just so that everybody knows, series might have some particular thing it does to prevent this from actually being an issue since it expects infinite sequences. But you can actually pretty easily trick the Common Lisp printer into printing something of infinite length or extremely long length. And there's actually a variable that you can set that will tell it not to print lists that are longer than a given size. Star print length star, print dash length star.
I think that's already defined in the series package.
If you're mucking about with this stuff, set that to some nice low value. I like setting it, around 100 in my init file, and then I'll set it like much lower than that if I know I'm going to regularly be dealing with really large stuff and I don't want it cluttering up my display. Yeah, just something to know.
I mean, that's an excellent point, and thank you for telling us that. I just wanted to bring up one point, though. At least with respect to series, some of the common things that are associated with interactivity are already defined in I think it is series.lisp. No, it's scode.lisp, which if you guys inspect, I think I can actually get there using. Dot? No, it was
comma GG.
Comma GG. Thank you. Let's go to. Let's actually do defund series is what I'm actually looking at, and this guy. So if you look at here, you already see that the series code is a little different than the common Lisp equivalents. Primarily, they now have a. Ooh, I'm wondering if this is the exported one that I have to use. I didn't realize that. That might be what I have to use. Okay, I'm going to make a note of this. Def-S looks like is what you want to use in their new API if you want to define a series function. Let me see if that's actually in the exported API. What? Just quit that. Let me just open up this previous buffer. Okay. I'll go and look at that later, and then I'll let you guys know with some updates in our meetup page and some notes onto this YouTube video. If
comma GB, by the way.
Comma GB?
Yes.
Oh, all right. Let's see this. GG. See. So.
Yeah, comma GG, comma GB.
Comma GB. All right, cool. All right. So I just wanted to bring up one other thing because I was already on there, and I thought I forgot to mention this as well, which is those of you when I was saying that series is a data type, it is a type we use that is following def type inside Common Lisp, and we never covered actually def type in our study groups. I know this is a precursor to probably I should actually do a series on def type and leveraging def type. I haven't done it yet because I haven't actually gotten enough experience with myself. Some of the more experienced Lispers on the channel, this is something that I think more people need to know about. I don't have enough real experience in order to talk about the nuances of it for me to do justice for it. So I wanted to at least, bring it up so folks who are available, who are experts or are fairly familiar with the Common Lisp type, if you guys can step up and, present, that would be an excellent, addition to this discussion. Let me just quit out of that and resize this a little bit so that we can continue going here. Are there any questions so far about what I've shown? Because this is, I know this looks kind of, we're jumping all over the place, but it is a very interesting library with different pieces that work sort of in conjunction with each other. All right. As I mentioned earlier, you can also use scan to actually create a series object. Now, you may have noticed that when we use scan, it creates essentially a series object with this hashtag Z. This is the reader notation for to represent a series object. In the original series macro implementation was a shortcut to actually run, I think, make series, and even it was a reader macro that you can leverage to actually create series objects as a shorthand as you were passing them into any of the series functions. Unfortunately, I don't know when they took it out, but they did take it out. It's no longer an exported symbol inside of the series library. They do encourage you to now instead use series scan or make series to create your series objects. I wanted to at least mention this because if you read some of the older documentation on series, a lot of the examples leverage this, and I was surprised when I was trying to run some of the examples that it didn't exist. So I'm mentioning that right now.
Yeah, probably for the best that they removed that. Just FYI, at least removed it from the defaults because there is no name spacing for reader macros.
Okay.
Those aren't package specific or anything because it would be rather tricky to really tightly associate reader macros with the package system. Mm-hmm. At least the way the package system is defined right now, and the way the reader macro system is defined right now. And so if they were to make it so that loading series added that reader macro, that would affect all code in the running system from the moment the series library was loaded. And so technically speaking, sure they can. I'm rather glad that they don't, though. Nowadays, we have libraries that let you manage what reader macros you have active on a file local level. Things like named read tables let you do that, and it wouldn't be terribly difficult, I suspect, to write a rather quick named read table for a series that would add that notation back in, and then it would be much more sane to use.
Thank you for letting me know. I mean, I was kind of curious about what would be a safe way of doing it, just because I sort of read that up when I saw this not being available, that it's not
Yeah.
good practice, but I didn't know how
you
you
should
fix it.
always be using named read tables when you're defining reader macros. They're just global, so I mean, to make them safe, you have to use it. I would not recommend not using that.
I'm wondering. I haven't had a chance yet, but I'm going to give a little plug here for another fellow Lisper who does these Lisp videos. Baggers actually has a very nice 2-hour overview of macros, and I think he covers reader macros and compiler macros on top of the introduction of macros that we've provided in our CL study group. So if you guys are looking into macros and trying to wonder what are these things and how to do these things, we have an introduction that follows Peter Seibel's approach to actually introducing it. But on top of that, Baggers, also another fellow Lisper, has a video series called Lots a Bit of Lisp, where he gives a nice overview of that information too as well. So check him out, because I like them. I like those
playlist
videos.
for the series is actually Little Bits of Lisp, and it's just the really long episodes he names Lots of Bits.
Yes,
in case people go searching for it.
That's a good point. Little Bits of Lisp is the playlist that you'd probably want to go look for, and Lots of Bits of Lisp is on macros is one of the videos. There's another video I think that it was Lots of Bit of Lisp on CFFI too as well.
Yeah. Anyway.
So on top of normal scanning functions where you could pass in a list or a vector, you can actually take in a list or a vector. You can actually also pass in what type you're passing into the scan function, and we'll go ahead and scan it accordingly. So in this example here that I'm just creating, I'm telling scan, by the way, my sequence object that I'm passing in is a vector, and it will go ahead and act accordingly for vectors. One of the advantages of this, of course, is this is not just list or vector, it's any of the subtypes that are available for list or vector. I think that are available. I know there are examples in the documentation that show scan getting passed in a simple vector and simple array. I don't know in what cases you would actually end up leveraging them. I'm only mentioning them here because if you see those examples, they will work just because those are subtypes of vector or list in their appropriate places. Additionally, this scan range guy that's available, this guy is actually kind of cool. It looks a lot like some of the loop stuff that we've done, and I will show you later on how some of the loop stuff that we've done, how we can actually go and essentially use collect with scan range to get the same functionality too as well. Obviously, as you can see in the signature, is not only from and up to and by, which is our step function, but it can also do below, down to, above, length, just sort of the same way as loop works. If you do not actually specify an up to or a down to, or I think it's above, this ultimately represents an unbounded collection of integers.
Does it still work if you remove the from zero? I know loop considers that optional in that context.
I think so, but I'm not sure. I didn't try it. Yes, it does work.
Oh, cool.
So it's a very nice, very versatile thing. It'll create an infinite collection when you need it for integers. I don't know in what situation. I mean, I use this sometimes when I'm playing around with creating like dummy data sets. But and I did create a dummy data set later on that we'll see when we use scan file.
The LDOC actually kind of gives away the from thing, by the way. It is actually properly the signature is actually probably properly documented to show that from is optional?
Sometimes.
No,
from is defaulted to 0, actually, if you can see it down there. So
that's true. LDOC doesn't always show you what the default value is, which is deeply maddening.
And by the way, if you don't specify by here, obviously by defaults to 1. So just by doing scan range, you end up getting the same, except it's incrementing to all the natural numbers.
512 is your length.
Yeah, my length is 512. Yes, that's correct. And as you can see here, in at least the slide description here, these ellipses just means it goes on and on. I don't know. I didn't add this inside. I think Series has, like I said, added this already.
That's actually the Common Lisp printer.
Oh.
It's probably using Common Lisp's Lisp printer, or no, it's probably using the. Anyway, it's a feature of the Pretty printer.
Okay.
That makes it automatically respect print length and print out an ellipsis if you go past it.
Gotcha. All right. I was wondering where that came from. I was like, I don't remember overriding this in any way. So
yeah. No. If it uses the Pretty printer properly, it'll automatically respect print length, and the Pretty printer will just insert the proper ellipsis if you go over the length.
Okay.
Because the Pretty printer is nice that way.
On top of scan range that being in scan, you have also the ability to scanplists, scan files. The actual scanning API is actually fairly extensive. It has scan list of lists, scan tree. I'm not providing all those examples here, but I do encourage you to look at the Series API documentation because if there is one, I think it covers most of the bases of most commonly used scans. But if there isn't one, you can always build one too as well because they have a generic higher order function called scanfn that you can use to create your own version of the scanning. I was trying before this broadcast to actually create an example where I'm reading from a socket and making an infinite stream from a socket. But I couldn't get it done in time, so I do apologize for that. Transducers. This is actually... Now, I wanted to talk to the more expert Clojurians that are in this channel just to discuss it, because this is a recent... most people know transducers from Clojure, being a transformation, and it's a reducing phase transformation that they generalize. Reading the series paper and the reference manual, I'm coming to the conclusion that transducers in series are equivalent to Clojure's transducers. Am I wrong to think of that, the concept like that? Like, is Clojure's transducers a little bit different? Anybody use them? Okay, that's a question that I will table then for future discussion, because that is something that I would like to eventually figure out. But it was
I would say that there's a lot of Clojure uses transducer to mean something much more specific than series does. But from a practical standpoint, there's a lot of overlap at the very least.
Okay. Because I don't have enough experience with Clojure transducers, so I didn't want to make an opinion of it. But I know folks who are watching this, who probably played around with Clojure, are like, "Oh, this is transducers. Oh, this is Clojure transducers." And I didn't know if conceptually they're exactly the same.
Clojure transducers are very specifically, a Clojure transducer is a higher order function that takes a reducing function, something like addition if you're adding numbers, or cons if you're putting together a list, something that you would pass into reduce, right? And it wraps it to perform some transformation to the values that you're then going to be reducing. And so, like a map transducer would, let you, apply some function to each of the elements before you send them into the original reducing operation. And so that would let you do something the same way, mapping a function over a list would, before passing it to, collecting the results of that into a new sequence. And so in Clojure, a transducer is very, very specifically something which takes in an existing reducer and produces a new reducer that does some transformation to the values that are being flowed in.
Okay, so in series, a transducer means it takes in a series and it transforms it into a new series based on.
Right.
So that's all it is. It's just a series of transformations. So it goes from series to series. An example of this that I got from documentation, and I'm showing you another way of actually creating series in this example to really, instead of using the scan, to actually illustrate that you could also make a series by calling make series with an item list. And it passes this into positions, and this transducer, all it does is it grabs the list of non-nil, the collection of non-nil positions, elements, and then creates a new series object out of the non-null elements. So if we go and evaluate this, you'll see that the index of the non-null elements is created into a series object here. In the case of if you wanted to grab them, you have this choose transducer that you can pass in a series object, what positions you want filtered out, and it will go through and given the source that you want to filter out from, it will go ahead and only return that sub collection that you actually wanted. So in this case here, if we evaluate it, you see that we only get 2 and 3 from the list because the second and third elements are set to true. To show you that we can get this from 2, 3, and 5, you can see that as soon as you say, oh, given this structure, I just want these positions, it'll go through and create a subseries from that. Collectors. Collectors are basically a set of accumulators. They will be able to do some statistics on your series. These are some of the predefined collectors. Again, I'm not going through all the collection or the transduction APIs that are currently available to you. It's, again, fairly extensive. But the most commonly ones used that I've seen in examples and that you will see is collect, which will just take a series object and convert it into, by default, if no type is specified, a list. So if we go ahead and evaluate collect make series ABC, you see that we get returned a list of our elements. If we pass in, of course, in the type signature, we can pass in the collection. It'll go ahead and convert this into and construct an actual vector of this. This, by the way, is actually a shoot. Did I say expand in a new window? All right. This expands actually into a fairly extensive piece of code that will go and construct a new vector, and then obviously set the vector's indices to those particular elements, and it will just pop through those series and generate them. Then we have a couple of base accumulation functions like collect sum and collect length that obviously does what they're told here. It'll pass in it'll create the sum of our integers here. Scan range also does the same thing. You can pass in either make series or scan range. And collect first. Well, collect length actually will give you the length of a series object that you pass in. Collect first will grab the first element. So in this guy example here that I generated here, which hold on, sorry, knee down. This actually grabs the first element of the first 10 even numbers. So here, if you go look at it, obviously, when we evaluate it, we get 2, which makes sense because subseries here, unlike take, which always starts at in other languages, there's a function called take that will grab like always the first uh, n samples from a unbounded lazy sequence or whatever sequence that you pass in. Unlike take, you can actually peek into using subseries and provide a starting element or a starting index in the series that we can start from, and then specify how long you want to actually grab the samples. So here we're grabbing, the first 10. Starting from index 10, we'll go to the first 10 samples, and then we grab the first element. I'm doing another similar example here of actually grabbing from subseries that we can go ahead and, scan through the elements, and then don't necessarily have to be a non-zero first element. You can use different types of elements here. We discussed this a little bit earlier, but I'm just going to go in a little bit more in depth on this. Like I said, that series is a metacompiler. As we mentioned earlier, that a lot of series overridden functions, which I think I could show here. Comma GG. Oops, not this one. I want this. This isn't there. All right. So this is actually part of the series package that I just wanted to show a little bit. You can see that in the series package itself, defun, let star are actually all part of the package. Hold on. Oops. Let me do that. And I'm going to actually...
define optimizable series function. Go comma GG back into that defun macro. If you note,
it's already here, is what you're saying here. Got it.
Yeah.
This guy. Define optimizable series function. Okay.
Yeah, but that's a function. Darn. Oh well.
Well, let me see.
Oh, that was so clever.
I thought, give me a second here. Do I have the package from the series object available? Yes, I do, actually. This is the one. I wanted to pull up the series documentation, just the package, just to see if I didn't miss anything here. So these here are what are available inside the series package. Is this too small? Should I increase the font? A
little bigger would be nice, but it's fine.
Okay, how's that?
That's perfect.
All right, cool. So let star, multiple value bind, fun call, and defun are all defined specifically into in the series package, and they're overwritten. So if you end up using series in your own code, I do actually, when you're defining it, I prefer you using series : defun instead of trying to see the warnings that I saw earlier. I'm just letting you know. Like, I originally thought that when I was reading the documentation, I could just use defun optimizable series function based on what the documentation said, but they've implemented it themselves. So
yeah, they're probably if you find the def package for series user, I think is the name of the package. I'm pretty sure you'll see that for that they're just for user.
It's not series.user or series user.
I don't remember.
Yeah. Okay. I'll go look this up. But
they're probably doing shadowing import from, which lets you pull a symbol from a particular package into your package, regardless of exporting or whatever, and overriding any other uses. And so you can shadowing import from defun from the series package. I'm pretty confident you could do that anyway. And then you wouldn't have to qualify it like that. But of course, if you do that, then anybody who uses that package now needs to know that defun isn't defun anymore.
Right, and that's that's where in my opinion, that's a problem. So
yeah, so it trade-offs all the way down.
Yeah, absolutely. But one of the nice things about creating these user-defined collecting functions is honestly, it creates just as efficient code as if you would have normally done it if you did it yourself, like through the iterative version. It's much more cleaner too, and it does some optimizations that I would have not foreseen for some of the more complex examples. Like I said, there was an example with bit sets and LVA that's in the documentation that I was unable to reproduce for the time today. But I will try in a future session also give you some more realistic examples other than some of these. This is just going to be a brief overview. So map was used a lot inside when series was being designed, and so they made a couple of convenience like transducers that would essentially generate the code that you would normally do if you used map fn. One of them is mapping, and then there's another one related to collecting, if I'm not recalling, or iterating too as well. The difference between iterate and mapping inside it with respect to series is iterate is for side effects. So if you're doing side effect based series transformations with the series object, you would use iterate. I don't have an example of iterate here. I could possibly create one right now. We could just actually do this. It'll basically look something like this. Iterate. And if I do this, I could just now do like normal even p x, and I can actually write code here and just print it out. When it's done, when it's all said and done, what ends up happening is iterate will return nil, and mapping will return the actual final collection. So here you see that nil is returned when you go through and iterate through this collection. But if I go in and actually call mapping, mapping will go through and actually generate a series object for you, return them. So you can use mapping as a basis of a more complex transduction versus using iterate. But if you're doing something that requires side effects, then iterate is available at your disposal. I wanted to end this with an example that I wrote, and this actually will show you some of the warnings. What I did was, as you can see here, I actually just generated a simple file that has a million integers in it with their squares, and I created this. I think I should have this already, but let me just make sure. No, yeah, it's not bound. I'll go ahead and do a compilation of it. Okay. This guy will just read in the file and create a parameter test file for us, which will host our integers, although for some reason it doesn't look like it's actually doing that right now. Weird. Why is it not doing it? Okay. So, if we go in and pass test file, you'll see that it actually generated it. One thing I wanted to show you is if we call collect sum on this file first, I'm going to show you the warning. You will get a warning saying that it couldn't figure out it couldn't go and figure out that whether it's a series or not. Although I went and bound it, I thought that was kind of weird. But I guess it makes sense, like that it didn't figure that out because it's bound by a variable. But if you look at the performance on this, because this is a million integers, what's nice about it is it's actually fairly. I've tried this before, and it looks like it's equivalent to running the same computation using let. So like in here, I just did a read first, just for an example, but I can do the same thing. Like if I do a time let x loop for I from 1 to a million, collecting I, and then of course I will create. I can do. Oops, let me do this. LST. I can do for I in list for j equals I, and then we could do for sum equals 0, then plus
Summing.
j. What? I could do summing.
Summing is a loop keyword.
Yes, that's right. Thank you. Now we can do finally return sum x.
No.
Summing, you can actually use summing like you were collecting.
Yeah.
To sum all the values.
To sum I and j. I didn't see that
you don't have
word
to do it
before.
manually with a plus symbol.
Okay.
Yeah, so sum plus ij.
Gotcha.
Replace your last two loop expression. The loop. Yeah.
He's saying sum plus ij. Gotcha.
Yeah.
Gotcha. All right. So this guy should give us 20% CPU. Yeah, and it's actually interesting that in this case.
Can you do one little thing for me?
Yeah, sure.
Put your cursor on the open paren before loop. And press space case C. Thank you. And now rerun that.
Okay.
Oh yeah, you were including the outer loop in the computation.
Yeah. That's a good point. I didn't consider that. All right. Why is this not?
Escape. You're in.
Oh, thank you. Okay, that's much better. All right. For a second there, I was like, "What the hell?" When I did this,
that was GC time.
Much better than series, even.
Yeah, it's much better than series. Yeah. I'm surprised actually. That's
series since that lazy sequence that series is creating probably hasn't actually read the file all the way. There's probably some I/O going on.
Yeah, that's actually a good point. I didn't even consider
There's
that.
no consing in the loop version. There's like 64 megabytes of data in the series.
Yeah,
version.
that I/O time is what's I mean, it makes sense. I mean, this here, I mean, just shows it, right? I mean, it makes sense what it's trying to do here. Let me do this. Space KC, you said?
So does scan file go line by line?
Scan file goes line by line.
No, actually, that doesn't make sense. It can't be going line by line because it has to be reading. Because you're getting integers. Otherwise, you can't be using collect sum.
No. What it? Let me just show you what it outputs a little bit.
Okay.
Right.
You're in smart parentheses.
Thank you. Yeah, that's what I was. It's still getting used to it. I apologize.
You will eventually. It takes a little bit though.
All right. Let me just go ahead and do this. And it should have already here, as you can see, it's going line by line. Let me show you the actual file. It might complain inside Emacs. I noticed earlier when I tried to open it, it was complaining.
Yeah, just tell it to open the file literally.
Projects, test.data, and is larger. Yes, really
Yes. We'll ask if you want to open it literally, say yes.
open. Yes. All right. As you can see, this is all what Scanfile basically took each of the lines and just constructed a series with it. So it's probably reading and parsing it to integers.
No,
I don't know.
It's not doing that. Because you have multiple numbers on each line.
Yeah, that's right. That's correct, and that's the reason why I did the sum earlier too as well. This is why I was doing this sum. The sum plus I plus thing. That's the equivalent of what this is doing.
Right. My point is that series is showing each of those numbers as separate elements in the series.
Right.
So it actually is processing element by element, which means it's probably just using read.
Oh, okay. That's a good point. It's probably reading it through as a stream and then constructing it in there. Okay. Right. All right.
Which means if you really want to see a fair comparison, I would say time loop with with open file, the file loop, and then for x colon equals read, and then pass the proper flags there to make it return nil on EOF, and then while x, and then sum x. Or, yeah.
With open file, let's try that. Actually, I do have this. I can just do this. We'll change this guy to the input, and loop for I equals read from the stream. And I should
Yes, you want to do stream nil, if I remember correctly.
Until...
Right, because that's EOF error P is nil, and then EOF value is nil.
Right. That's I think that's correct. Yes, EOF P error is nil, and then EOF value is nil. And then you want me to do sum I.
Well, you want to do the 4j equals, I times I. If you really want to be fair.
No, I don't have to, because it's getting it from the stream, right?
It's already in the thing, yeah.
Okay, good. So,
and then time that.
Yeah, and I just do, you said space KC once I get into the...
No.
Here.
That won't help you there. Space KW. Wrap.
Space KW. You did space KC in the let, though. I didn't...
Yeah.
You probably want to time inside with open file, so you're not timing the...
Yes, that's true.
IO required to open the file, yeah.
Yes.
Actually, go undo. Undo.
Okay.
Undo. Undo.
Okay.
Undo back till you had the time.
Oh, got it. Well, I basically took that out. Give me a second.
Oh well. Too late now.
Why is that?
I was going to show you what Space KC does.
Oh, all right. Let's do this. Space KW time. All right. So what does space?
And then unwrap that loop because you've got an extra pair of parens there.
I do.
Space K, capital W.
Capital W. Got it. All right. And let's make sure I am. Okay.
Yeah. Good. Now put your cursor at the open paren of the loop.
And then do space KC, right?
Yes.
Okay. Gotcha.
It's called convolute.
Got it.
You see what it did?
Yes, I did. I saw what it did, and that's exactly what I wanted to know. I was like, okay, this is interesting. All right, so let's see.
It's reversible. So if you go back to the open paren of the loop and you hit space KC again, it'll swap them back.
Okay.
You can keep doing it, and it'll just keep swapping them.
Nice.
What it is it takes everything in the immediate parent list all of the things before the current item,
Oops.
and it swaps them with all the things before that parent list in its parent list. If that makes sense.
Okay. All right. So
If you keep playing with it, it'll be clearer.
let's
It's specifically for that particular use case. It does that one thing very well. Like if you have like a width nested inside a let and you swap them around the other way around, if you have a bunch of widths and you need to reorder them, convolute handles that case for you.
Interesting. And let's see what happens here if we do this. So now we have 64 megabytes cons. Let's do this one. Let's see what happens. It should do the same. It's going to take a little while, actually, because running this experiment, it's actually looping through it now in real time.
Yeah, actually, this would probably be a lot slower.
Yes.
A lot slower.
It is a lot slower.
But it doesn't cons anymore.
Yeah, it still doesn't cons. That's amazing, actually. It still does not cons. I don't know what it's do. Loop is doing something. I have to figure out what Loop is doing behind the scenes.
It's not Loop. I almost guarantee it's not Loop. Loop is not the difference here. I mean, I almost guarantee that it's actually that they're probably using like some special thing in there for like parse integer or something like that instead of relying on read, which would be a lot faster. But that requires that you like know what you're doing and write really clever parsing code.
Well,
And
okay,
it's
I'm
outside the
gonna
scope
make a
of
note of figuring out what series is doing, and comparing it what Loop is
I
doing.
would like to see one last thing though, which is if you don't have the test file bound to a dynamic variable instead of it bound to like a local variable.
Okay, let's do that. Let me take this guy out. I'll just rewrite it. Not a big deal.
Yeah.
Let
and series let.
all right, thank you. Series let. I'll call it a file descriptor here. Series is what I'll call it. Scan file. Let's projects test.data. Okay. And time collect some F series. Okay, this should be exactly the same.
That probably will throw warnings at you now that I think of it. Try it. I want to see what happens.
All right. Just evaluated. It's just sitting there. Interesting. It's probably reading in the file. Okay.
Okay. So
Yes.
scan file must eagerly read the file in them.
That's what I was expecting actually earlier too. But I didn't get it. And I was like, okay, it must be something that series is doing that's slowing it down that I'm doing wrong, but I didn't think about using series let there. Huh. All right.
Yeah, actually, can you move that time all the way out?
Yeah, sure.
I'm suspicious of that.
Oops. What the heck? Collect some. Okay. See. All right. Right. Turn. The heck? Oh, it's done already.
No, it's not.
You know what? Restarting my. Hold on. This is.
It's still running. There it goes.
There we go. 7 seconds. Ooh. 7.5 seconds.
About 7 seconds.
That's
a lot less consing.
Yeah, but still, I mean, that's actually A couple of times. The first time it was at 8,000. It's dropping over time. It's probably because of caching effects
Probably.
in the process. Um, what the number of CPU used is less than 50%. So
Yeah, you're I/O bound.
yeah,
Yep.
significantly I/O bound. All right. So this obviously has been a short but very interesting overview of series. Are there any questions from the audience? I know that Michael, Elijah, and I have been dominating the conversation. Judd, do you have any questions?
No, I think this is another great class, man. I really like watching you go through this stuff I don't know and have the other guys help out. It's really valuable.
I mean, I'd like to show a couple of other realistic examples. Obviously, I haven't gone through all the details. I do encourage people to look into at the series library. It is a really cool library. I feel bad that it wasn't actually in the Common Lisp standard, but it's one of those cool. And we haven't even touched some of the things that series actually grabbed from Appendix B, because if you guys look at the Common Lisp second edition, there were two parts associated with iteration that did not get into the standard. One was series, and the other one was gatherers and generators. And it turns out that the series package has also gatherers and generators. And I haven't had a chance to really play around with them, so I can't really speak to them. But that will be a topic for another time that I would love to go through.
And eventually, I would actually really like to demo Screamer. I just don't know if that'll ever be something I'll have time to really do seriously.
Do it, man. Just do it. Even if it's a small one, I would love to see that, because I think you mentioned it before in
Yep.
another talk, and it is something that I think people should look into. But that's all I have for today. Are there any comments from anyone watching the stream? Doesn't look like any comments from people watching the stream. Richard, do you have any questions? Looks like he's just watching things along. Oh, good. Okay, cool. Well, if there's nothing else, next time, Michael, will you be available to give your introduction to game programming by chance?
That's the plan.
All right. Sweet.
Let's shoot for that. I just started a new job, so my time is limited, but I'm going to try to make time for that, because it's been something I've been talking about for a long time now.
Excellent. Thanks a lot, Michael. So, guys, next week, hopefully, knock on wood, if all goes well, we'll be having a very nice discussion on introduction to game programming. Maybe in a few weeks we can actually convince Elijah to give a talk on Screamer, time permitting. But until then,
probably have to wait till I'm back from my travels.
Gotcha.
We'll get into that right now, but at least a week or two. Once I'm back home, I'll have a lot more time to look into that.
Sweet. So we have game programming and hopefully Screamer in the next few weeks.
And by the way, that
Yay!
that bug I was talking about, where you have to manually delete the slide description buffer.
Yes.
That is really not a bug. The reason why you have to do that is because slide description is not implemented as a major mode. It's actually using Lisp mode.
Gotcha.
Because Sly loves to do that for some reason that I cannot explain. It loves reusing the Sly major mode everywhere it shouldn't.
So you're saying that we have to go into the Sly code and fix where it's using Sly?
No. Probably just it would probably be enough just to set the default evil state to motion state. I think maybe. I think that was a binding for Q to bury buffer. Anyway, stuff we'll look into eventually.
Okay. Sweet.
Regardless, there are ways around that. Probably, worst case, just create a quick minor mode that gets enabled and that has that binding.
Well, I guess this is a bunch of nice offline discussion that we can have.
And Elijah, while I'm at it, I don't know if you got my message, but there is a open issue on the Common Lisp Sly GitHub issue tracker due to a piece of code you had me add to it that I'm not sure how to fix properly. If you want to take a look at it at some time.
I'll take a look at that. No promises I can do much, but I will take a look.
Okay, thanks.
Sweet. All right, then. I guess this is Ron Batum signing off. Thanks a lot for joining us. This has been a great discussion. Thanks a lot to Michael and Elijah, and thanks for our frequent visitors for joining in on the stream. Until next time, I'll see you guys later, man.
All right, great.
Thanks a lot.
Thanks.
Yeah, great time.